Hello everyone, I welcome you all to this class. This is mathematics class and today we are looking at this example 2 under this topic we have introduced in our previous video, solution of ODE. So we are looking at solution of ordinary differential equation. Now, in this example, in our previous video we saw the first example and we said that a particular function is a solution to a given ODE if that function satisfies that ODE at all points of the independent variable on the domain in which the function is defined. Now we are having this example. They ask us to determine for what value of v each of the following ODE has a solution of the form y equals exponential vx. So in this question, they have already told you that a solution of the form y equals exponential vx will satisfy these ODEs. So this function now will be a solution of the given ODEs. They have already told you. You are not checking whether it will be a solution or not. They have told you that it's a solution, but we want to find that value of v that will make each of them a solution of the given ODE. So solution. So let's look at the first one. The first one, given something, given y prime plus 2y equals to 0, right? And what is given to us is again y equals exponential vx. So this is what is given to us. I've written them down for the first question. Y prime plus 2y equals 0, and y is exponential vx, which you can put it here, but we don't know our y prime, so we need to get our y prime so that we can substitute them here and now solve the equation, right? So we are going to have something y prime. If you differentiate this if you differentiate this function, what will you get? If you differentiate exponential vx. So how do you differentiate the exponential function? You differentiate what is on you differentiate the exponent. What's the exponent? The exponent is vx. So if you differentiate vx, what will you get? You get v, right? If you differentiate vx, you get what? V. And use the v to multiply the exponential. So you have v exponential vx, right? If you differentiate the exponent, this exponent, you get what? V. And use the v to multiply the exponential. That's what I have written down there. So when you have done that, we can now substitute. So let me call the given equation 1. So let's substitute, right? Let me call this one equation 2 and call this one equation 3. So you can say substitute equation 2 and equation 3 in 1. So let's substitute. So coming to this equation, we now put them. So what is y prime now? Y prime is v exponential vx plus 2. What is your y? Y is exponential vx. Exponential vx. And they say that this function will satisfy the ODE, so it's supposed to give us what is at the right hand side, 0, since it satisfies it, right? We now solve to get our v. What is common is what? Exponential is common, so factor out exponential vx is common, so factor it out. Exponential vx, open bracket, v plus what? 2 equal to what? 0, right? And factor out the common one, exponential vx. So when the product of two quantities are giving you 0, what does it imply? It implies that this equals 0 or this equals 0. But we know that exponential, something can never be 0, right? Exponential, there is no number, if I have exponential x, there is no number that I will put here for x that will make this exponential to be 0, right? Exponential cannot be 0. So since exponential vx is not 0, so it implies, and this product is giving you 0, it implies that this one will be 0. It implies that what v plus 2 will be what 0. And if you move positive 2 to the right hand side, you now have that v will be equals to what? Negative 2. Because if you move positive 2 to the right hand side, it changes to negative. Right? So that's what you have. So we have gotten our v in this case, right? So our v is negative 2 in that case. So for the second one, for the second question, we are given that y prime minus y equal to 0. So that's what is given to us, right? And the solution is given by y equals exponential vx. Exponential vx. So I'll call this one equation 1. Call this one equation 2, right? Then let's, as usual, since this function satisfies this ODE, so if you substitute the function and its derivative, is supposed to give you what is at the right hand side. So the function, which is my y, I can put it here, but I don't have the derivative yet. So I have to differentiate it to get the derivative, right? So y prime now, if you differentiate it once, we have, for the first one, we have already gotten the value for the first derivative. See the first derivative here. It gave us v exponential what? Vx, right? So what will be y prime prime? If you differentiate this again, what will you get? To differentiate this again, you will differentiate what? The exponential. Remember, you are differentiating with respect to x, right? If you differentiate what's on the exponent, if you differentiate vx, what will you get? You get v. You know how we got v? Because the power of x is what? 1. So what do you normally do? You bring down the power, right? 1 multiplying vx. You remove 1 from the power. You now have v x raised to power 1 minus 1 is 0. And x raised to power 0 is 1. So you have v, right? So if you differentiate the exponents, if you differentiate vx, you get v. Then you use this to multiply the whole exponential function. So you have v multiplying the whole of the exponential function, v exponential vx. So that's how to differentiate the exponential function. You differentiate the exponent, use the result to multiply the whole of it. I differentiated the exponent, I got what? V. I use it to multiply the whole of the exponential function, and I have this. So this will give us what? V multiply v is v squared exponential vx. So what do we call this? We can call it equation 3. So why we differentiated again is because we need it. We need it in this equation. We need to substitute y prime prime. And we need to substitute what? Y. We have already known our y. Then differentiating 2 times will give us our y prime prime, which is the second derivative. So we can now substitute, right? Substitute equation 2. Substitute 2 and equation 3 in 1. So let's substitute. Substitute equation 2 and equation 3 in equation 1. These are equation 1, right? So our y prime prime is v squared exponential vx. I will put it there. V squared exponential vx. I have substituted this quantity for y prime prime minus, what is our y? The given solution, right? Exponential vx. And since they told us it will be a solution of it, it will satisfy the ODE, right? Equal to 0. It will give us the right hand side. So we can solve this equation, right? What is common is what? What is common is exponential vx. So we can factor it out. So exponential vx, we have open bracket v squared minus 1. If you factor out exponential vx, what will now remain is v squared minus 1, right? Then equal to the right hand side 0. So as usual, since exponential vx is not 0, I've explained it earlier for the first one. It implies that what? This quantity will be 0. V squared minus 1 will be what? 0. Because these two products are giving you 0. So one of them must be 0. but exponential vx is not 0 because exponential cannot assume a zero value. It can never be 0. So it means that at this point that will be 0. So with that, oh, so this implies what? We can move negative 1 to the right hand side to change to positive 1. So we have now v square equals to positive 1. And you can take square root of both sides, right? Take square root of both sides. We have that v, put square root here. Square root will cancel this square. Then put square root here. You now have square root of 1, but you have to do plus, that's plus or minus square root of 1, right? Plus or minus square root of 1. So this will be equal to what? This implies this will be equal to so if you do plus or minus square root of 1, square root of 1 is what? 1. So you are going to have implies that v is equals to plus or minus what? 1, which implies that v is positive 1 or negative 1. So these are the two values of v for that. So remember, it's the values of v we are getting for which this exponential vx will be a solution of the respective ODEs. So we can proceed. Let's look at the third question. So for the third question, we are given that y prime prime plus y prime minus 6y is equals to 0, right? Then the solution given to us is y equals exponential vx, right? So this one I can call it equation 1, and this one I call it equation what? 2, as we did earlier, right? So now this is a solution to that given ODE. It's a solution to the given ODE. So what do? We need our y prime prime, we need our y prime, and our y we already have it. So if you get them, we can substitute them in this equation, and it will satisfy the ODE. It will give us what is at the right hand side, which is 0. Then we'll solve the equation and get the values of v. So the values of v and what we are just looking for the values of v. So right, we can say y prime will be equal to what? We have gotten y prime before. You can see it here. We have done it before. So it gave us what? V exponential vx, right? And y prime prime, we have already solved it before. See the answer here. It gave us what? V squared exponential vx. So right, let me call this one equation. Let me call this first one y prime will be equal to v exponential vx. Can call it equation 3 and call this one equation 4. So we have gotten the respective derivatives. So what do? Substitute, right? Because the given this thing is a solution to the ODE. So we substitute 2, 3 and 4 in 1. So substitute this one for y, substitute this third equation for y prime, substitute this fourth equation for y prime prime in that given ODE. So this implies what? Y prime prime is, the value is this one, v squared exponential what? Vx. Then plus, what is your y prime? Y prime is v exponential vx. Then what is your y? Y is exponential vx, right? So we have negative 6 exponential vx. And this is a solution of the ODE, right? Equal to 0. So you satisfy it, it will be equal to the right hand side. So what is common is what? What is common is exponential vx is common in all of them. So we can factor it out, or if you like, you divide through by exponential vx. So if you divide both sides by exponential vx, this implies, if you divide here by exponential vx, we have v squared, right? We have v squared. Divide this one by exponential vx, we have v. Divide this one by exponential vx, we have negative 6, then equal to 0. So this one, what we got now is a quadratic what? A quadratic equation. So let's see if we can factorize. Let's see if we can factorize the quadratic equation. So we consider the one with the highest index. That's this one, this term with the highest index. I have v squared. What is the coefficient? 1, right? 1 is the coefficient of v squared here. Then the constant term. The constant term is the one that does not have a v attached to it. That's this negative 6. Use the constant term to multiply the coefficient of this one having squared. So the coefficient is 1. So negative 6 multiply 1 is still negative 6. So look for the two factors of this negative 6 that will give us the coefficients of the middle term. What is the coefficients of the middle term? 1. So we look for two factors of negative 6 that will give us the coefficient of the middle term, which is 1. Let's consider negative 2 and positive 3, right? Negative 2 multiply positive 3 will give us negative 6, right? But let's check if the sum will give us the coefficients of the middle term. 2 negative 2 plus 3 will give us what? Positive 1. So the sum gave us the coefficients of the middle term, right? So that the middle term can be written as negative using this one, negative 2v plus using this one 3v. That's the middle term can be written like that. So that's equation. We have v squared minus 2v plus 3v minus 6 equals to 0. We have factorized it. So this implies v is common for these two terms. We factor v out. We have if factor v out, use v to divide v squared, you have v. Use v to divide negative 2v, you have negative 2. Right? What is common here? The common factor here is what? Positive 3. Right? So positive 3 divide 3v is v. Positive 3 divide negative 6 is negative 2 equals to 0. So this quantity can be written as, you pick the coefficients of the first bracket and the coefficients of the second bracket. So we have v plus 3. Then the two brackets that are common, so we pick one of them, v minus 2 equals to 0, right? Now this product is giving you 0. What does it imply? It implies that either one of them is 0. So we have that v plus 3 is equals to 0, or v minus 2 is equals to what? 0. So the product is giving us 0. So it implies that for one of them will be 0. So if you solve the first one, move positive 3 to the right hand side, you have v equals what? Negative 3. Or if you solve the second one, move negative 2 to the right hand side, you have v equals what? Positive 2. So these are the two values of v. So with this, we have concluded this part. We have gotten the respective values of v, for which exponential vx is a solution to those given ODE. So thank you so much for being part of this class. I'm expecting you in our next class.